Hello there, everyone. My name is Crazy Caleb, and today we're going to be taking a look at the dials. So this is the way the module looks. It's got a series of 4 different dials and a center display that can display a letter, and once you interact with the module, it will display some numbers as well. So let's get into this module. So what exactly are we going to be doing here? So we need to figure out a series of different numbers we're going to set each of the dials to, and then based off of the letters in the center. So the weird thing about this module, and it looks very intimidating at first when you go through all this, however, I will explain to you that it's actually really simple. It's a lot of really simple rules, but there is some things that you need to pay attention to. One of the first things that I need to explain is dials start at 1 from north and increase going counterclockwise. So that's the way that we're going to get our read. We're going to start from the north, going counterclockwise. So we're going to get Lima, Charlie, Echo, and Oscar. And that is going to be our read that we're going to get here. So what we're going to do is we're going to go through dial 1 respectively from the top, going counterclockwise, dial 2 with our flowchart, dial 3 with the instruction list, and dial 4 with the table here. Pretty straightforward. So dial 1 is a Lima, and we have this little grid here. Now, one of the most important rules that I would like to point out before we even begin this thing. If there are no batteries in ports present, we're going to set all dials to 1. This is basically our unicorn right here. So we do have batteries. So we almost didn't have any ports though, mind you. So we are not going to be setting all dials to 1 because there are batteries present. But keep that in mind because this is one that I've actually had mess me up as a unicorn. So let's take a look at the dials. So for our first one, being north, and we're going to go counterclockwise for each one, we're going to be taking a look at this Venn diagram and applying a rule that applies here. So the first rule of this Venn diagram is serial number shares a letter with a module, with the module rather. So do we have any of these 4 letters present in the actual serial number? Papa, and Sierra, none of those guys are present, so that's not true. Next up, there is an indicator that shares a letter with the module. Looking around here, there are actually no indicators present on this module, so that's not true. Next up, repeated letters on the module. This refers to having duplicate letters, basically, and we don't have any of those. And lastly, second or fourth letter on module is a vowel. Second or fourth. Well, the only one that we have is a vowel. Oh, no, we actually do have a vowel in the 4th position. That is an Oscar. Oscar is in the 4th position. That is a vowel. So this rule is true because it is in 2nd or 4th position that has a letter that is a vowel. So this is the only circle that's true. So this corresponds to a mic. And Mike's rule wants us to set this dial to 6. So now what we're going to do is we're going to tap this dial until the center gives us a 6. Note that the numbers are in random order, but there will always be one of each number present until you get back up to north. So that's that first rule set. That's the first rule done. Next up for dial 2, we're going to focus on the flowchart here, and then we're going to be focusing on Charlie here. So as the start of it, are there any indicators that share a letter on the module? No, that is not true. So we're going to be going over to this rule. Are there any RJ45 ports? No, that is not true because we don't have any ports or indicators. We only have 2 batteries and 1 empty port plate. So there are no RJ45 port presents. So we're going to go down to here. Is the last digit of the serial number even? The last digit of the serial number is odd. So this is going to be a no from this rule, which gives us a 2, and this is where we're going to set the dial from upon reaching a number. So we're going to set the dial to that position, which is a 2. And just like that, it's right there. So next up for dial 3 is the instruction list. So now we're going to start with the number 1. We're going to add the number of ports. Ports is going to be 0. Batteries is going to be 2. So that'll be 1 plus 2 is 3. Port plates, there's only 1 present, so that's going to become 3 plus 1 is 4. Battery holders is just 1, so that's going to become 5. Indicators, we don't have any indicators. And solvable modules, including itself, that is going to be 1 on the module here. So we're going to have 5 plus 1 being 6. Next up, we're going to multiply the number by the calculated digital root. This is for numbers that are larger than this. For example, let's take let's take 42 for example. So if we take, or 16 rather, if we happen to get a sum of 16, what we're going to do is we're going to keep 16, but essentially what we're going to do is we're going to multiply by the digital root, which is the sum of all the digits being, until it's one digit left, 1 plus 6 being 7. What we're going to do is we're going to multiply this number by 7. That's the way that this works. So we're going to do 16, we're going to multiply 16 by its digital root by itself. That'll be 7. And then we're going to add 1. However, we have the number 6 here. 6 digital root is going to be 6, so we're going to simply be multiplying by 6. So 6 times 6 is 36, and then we're going to add 1, so 37. Then what we're going to do is we're going to change all of the letters on the module into numbers, so alphanumeric position, A1, B2, etc., etc. Lima is 12, Charlie is 3, Echo is 5, Oscar is 15. I know those off the top of my head, so just mind deal with that. And with this, we're going to pull out our handy dandy calculator now, and we're going to add the first letter to the number, adding 12, so 37 plus 12. And then we're going to subtract the second letter, minus 3, multiply by the third letter, excuse me, times this by 5, and then divide by the fourth letter, divide by 15. And now we're going to ignore, we're now going to ignore the decimal part, which is going to leave us with 15. And what exactly do we do with this number? After following all instructions and performing all calculations, modulate the number by 8, and then add 1, and then set the dial to that number. This is probably the longest part of it all because it is a lot of just math that we have to do. So 15 modulo 8, or subtracting the number until it is less than 8, so 15 minus 8 is going to give me 7. 7 plus 1 is going to give me 8. Is going to give me 8, and this is what we're going to set dial number 3 to. And just like that, it's back at 8. And now we're going to move on to the final step. The final step, probably the simplest part, is the table. So the columns of this table represent the first letter on the module, and the rows represent the third. So all we're simply going to do is highlight the first and third letters, first representing the column, which is a Lima, the rows representing the third, which is an Echo, and this is what we're going to set our number to, 8. And now once everything is all set to all of our numbers, what we're going to do is we're simply going to press the submit, the middle to submit. And just like that, this is all module. Pretty straightforward, nothing too special about it, just a bunch of sometimes weird rules. Let's take a look at another example. And I'm going to go through this a lot faster. Now, of course, taking a look at the first rule here, if no batteries and no ports are present, however, we do have batteries and ports, so we're good to go. Excuse me for a second. Apologies for that, I'm back. So now, let's do the same thing we did before. Let's make sure we gather everything counterclockwise. So we have November, Delta, Delta, and Lima. And now let's take a look at each of the dials here. So for the first one, we're gonna see if the serial number shares a letter with shares a letter with the module, which it actually does immediately. We have a November present in both the serial number and the module, so this is going to be true for this circle here. Next up, there is an indicator that matches that shares a letter with the module. Let's take a look at our indicators because we have quite a few on here, and already taking a look. Noticing that the lit or unlit status does not apply here, we can take a look at this Charlie Lima Romeo, and there is a Lima present in our module, so this circle also applies on the left here. Next up, second or fourth letter on module is a vowel. We don't have any vowels present at all, so we're just simply going to say that rule is false. And repeated letters on the module. This rule is true because we do have 2 deltas present here. So this circle's true, this circle's true, and this circle's true. Their intersection is going to be at a Charlie right here. And Charlie wants us to set the dial to 8. So for our first dial right here, we're going to set that number to 8. Just like that, that's good to go. Next up, looking at our flowchart, are there any indicators that share a letter with the module? That rule was true. We had to have a Lima right here. So this is going to go down to yes. Now, are there more AA batteries than D batteries? No, there are more D batteries than AA. That is not true. So that's going to be a no. And lastly, are there any stereo RCA ports? No, there is a serial port present. That is not what we're looking for, though. So that's going to be a no. That'll be down to a 1. The second dial will be in a 1 position, just like so. So next up, the instruction list, probably the longest part of this. Let's convert our numbers, our letters to alphanumeric positions. Like so, 14, 4, 4, 2, or 4, 4, 12. Excuse me. We're going to start with the number 1, and we're going to add all the edge works. So we have ports. There's going to be 1, so that's going to be 2. Batteries, there's only 1 present, so that's going to be 3. Port plates. Port plates is just 1, so that's going to be 4. Battery holders is another 1, so that's going to be 5. Indicators, there's going to be quite a few of these. We have 1, 2, 3, 4, and 5, so that's going to be a 10. And lastly, the number of solvable modules, again, is 1. However, on bigger bombs, we need to remember that that is going to happen like 47s or 101s. Keep that in mind because that is going to be important. It is itself, and it does not include needies. Solvable modules do not include needies. Next up, we're going to take the digital root of that sum, and then what we're going to do is we're going to multiply the number of the calculated by the calculated digital root. So we're going to keep the 11 right here, and we're going to calculate the digital root, which is a 2. 1 plus 1 is 2. And we're simply going to multiply this guy by 2 right here. So now 11 times 2 is going to give me 22. And then we're going to add 1 to this, giving me 23. And now we're going to do the same thing we did before. So we have 23 here. So then that's going to be by, so we're going to be adding the first letter, which is 14. And we're going to subtract the second, which is 4 minus 4. We're going to multiply this by 4. And we're going to divide this by 12. Oh wow, that's actually that's a perfect multiplication. So we're going to ignore the decimal part, which there is no decimal part, and now we're going to simply modulo this number that we got, modulo this by 8, mod 8, and then we're going to add 1 to this guy, and this is going to be the position that we're going to set the dial, the third dial to, and just like that, there we go. And lastly, the table. The table is going to be a November, which is the fourth letter on the module, as the column, and delta as the third letter, which is the row. That is going to be a 5. That is going to be 7. And now everything's set in its correct position. Let's hit the submit button. And just like that, it's all module. Let's take a look at one final example, because this module does get you into a rhythm, but it is pretty straightforward with how the instructions are. So we have Echo, India, Lima, Romeo. Echo, India, Lima, Romeo. All right. Let's check the serial number to see if any of these guys share a letter, and making sure that we also check our unicorn. No batteries. There are batteries currently present, quite a few of them, mind you. So that is not going to be true. Now, our serial number. Does it share a letter on the module? There is an echo present, so that is going to be a true case. So this circle is going to be true. There is an indicator that shares a letter with the module. TRN. TRN shares it with a Romeo here. We have Romeo and Romeo, so that circle is also true. The second or fourth letter on the module is a vowel. The second letter is an India, which is a vowel, so that rule is true. And lastly, there are no repeated letters on the module, which means that we have top, left, and bottom circles are true, which intersects at a foxtrot. Foxtrot's rule wants us to set the dial to 4. And just like that, there it is. Next up, the flowchart here. We did have an indicator that shares a letter with the module, Romeo being right here in TRN. So that is a true. Now, are there more AA than there are D batteries? Let's take a look around. In this case, no. The number of D batteries is 2, and the number of AA is 2. So these guys are equal, but and AA is not more than D batteries. So this rule is going to be no. So we're going to follow the no again. And are there any stereo RCA ports? There are not. We only have we don't have any ports at all present. So that is going to be a 1 again. And just like that, we're at the 1. Next up, we're going to convert everything to alphanumeric stuff here. 18. Starting with the number 1, we're going to have the number of batteries, which is 4, so we're going to have 5. Number of ports being 0, port plates being 0, battery holders being 3, that's going to be 5 plus 3 is 8. Indicators is 1, 2, that's going to be 8 plus 2 is 10. And solvable modules, 11, and I'm pretty much already seeing kind of where this path is going to go. So the digital root of the sum that we get here is going to be 2, and now we're going to multiply this 11 by 2. So now, okay, so now we're going to do 11 times 2, giving me 22. Then we're going to add 1, giving me 23. And now we're going to do handy-dandy calculator work. 23 plus 5 minus 9 times this by 12. And then divide by 18 gives me 12. We're going to drop the decimal part. And now we're simply going to modulo this guy by 8. 12 modulo 8 gives me 4. 4 plus 1 will give me 5. So that will set it to the correct position. And finally, for the table, Echo is the first letter, Lima is the third, and lastly, our last number is going to be 8. Everything's set to its correct position. And just like that, this is all module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye.